Most tiny house builders pick a gable roof without thinking twice. It is what they have always seen. It is what feels safe. But here is what nobody tells you. The flat roof tiny house is quietly becoming one of the most compelling builds in the entire space. And the people who figured it out are living in homes that look like they belong in an architecture magazine, work smarter in the right climate, and actually give them back something most tiny houses just throw away: usable space above their heads. And the irony? The reason most people avoid it is a problem that, with the right build strategy, is almost entirely solved by 2026. I'm talking about waterproofing. And by the end of this video, you're going to know exactly how to get it right. Before we go any further, if you're new here, welcome to Affordable Tiny Homes. We research the real numbers and real design decisions, so you do not have to learn them the hard way. Hit subscribe and turn on notifications, because we drop new content every week and you do not want to miss what is coming. And stick with me through this whole video, because near the end, I am going to reveal the single waterproofing mistake that causes most flat roof failures. And it is not what you think. Here is what we are covering today. First, we're going to walk through exactly what makes the flat roof design so powerful for a tiny house specifically, not a mansion, a tiny house, and why the proportions actually work in your favor. Then we're getting into the 4 real modern design moves that make these builds look so clean and intentional. After that, we go deep on waterproofing, the membranes, the layers, the slope requirements, and the costs, with current 2026 pricing, so you have actual numbers to work with. And then, right at the end, we're going to talk about the one thing that flat roof builders consistently do wrong that causes the whole system to fail early. Stay until that part. It will save you thousands of dollars. Let's start with a question. Why would anyone choose a flat roof on a tiny house when pitched roofs shed water automatically and have been proven for centuries? The answer is threefold: aesthetics, functionality, and the unique math of a small footprint. On the aesthetic side, a flat roof gives a tiny house extremely clean, horizontal lines. No triangular peak. No dominant roof shape competing with the walls and windows. The structure reads as a cube or a rectangle, which pairs beautifully with modern exterior finishes: board and batten, dark stucco, cedar cladding, or fiber cement panels. These homes tend to photograph extremely well and hold their visual appeal across changing design trends because the geometry is so simple and pure. On the functional side, the flat roof opens up a set of possibilities that a gabled roof simply cannot offer. You can install solar panels at optimal tilt angles without fighting your roof pitch. You can create a rooftop deck, usable outdoor square footage that does not take up any footprint on the ground. You can set up rainwater collection systems more efficiently. And you can integrate a green roof or living roof layer if you want natural insulation and stormwater management. And then there is the math. On a standard gable roof tiny house, the roof system is a significant cost line: labor, framing, sheathing, felt shingles, ridge vents. Flat roof construction uses fewer materials, requires less complex framing, and reduces labor hours. That matters when your total build budget might be under $50,000. Now, there's an important thing to clarify right now that surprises a lot of people. A flat roof is never actually flat. That is one of the most common misconceptions in residential construction. Every code-compliant flat roof is built with a minimum slope of 1/4 inch per foot, roughly a 1 to 2% grade, to encourage water to drain toward gutters, drains, or scuppers. It looks flat to the eye. It functions with gravity doing the work. And here is the key insight for tiny house builders specifically. The most cost-effective way to build that slope into your roof is not to add taper insulation on top. It is to cut the slope directly into your ceiling joists and rafters during the framing stage. On a tiny house where interior height is precious and overall structure height matters, especially if you are working within a 13.5-foot mobile limit, building the slope into the frame keeps your roof assembly thinner, your costs lower, and your vertical space intact. That built-in slope is why flat roofs work. And when it is paired with the right waterproofing system, which we are about to break down, they perform reliably for 25 years or more. Now, let us talk about design. because a flat roof tiny house is only as good as the design decisions that surround it. Here are 4 moves that consistently separate the builds that look incredible from the ones that just look like a box. Design move number 1, the cantilevered roof extension. One of the most visually striking things you can do with a flat roof is extend it past the exterior wall on one or more sides. This overhang, sometimes called a cantilever, does several things at once. It creates a strong shadow line that gives the structure depth and dimension. It provides natural shade over windows and doors, reducing heat gain in summer. And it creates a covered outdoor zone that feels intentional and architectural rather than tacked on. Even a 12-inch extension changes the entire reading of the building. A 24-inch overhang makes it look like something from a design magazine spread. One important note here, if you're building a tiny house on wheels, keep overhangs modest and low profile. Deep cantilevers on a mobile build face serious highway wind shear, lifting forces at speed. On a stationary build on a foundation, pier system, or slab, you have full design freedom. On a THOW, keep it close to the wall and keep it clean. Design move number 2, full height windows on the long wall. Flat roofs allow you to run windows from floor to ceiling without fighting the structural demands of a pitched roof. On the south-facing wall of a tiny house, floor-to-ceiling glazing does multiple things. It floods the interior with natural light, which makes small spaces feel dramatically larger. It creates a strong visual connection to the outdoors, which reduces the psychological compression of a compact footprint. And in a well-designed passive solar layout, that glass wall becomes a thermal asset in winter. Modern flat roof, tiny house builds increasingly pair this glazing with deep overhangs. The overhang shades the glass in summer when the sun is high, and the lower winter sun angle passes under the overhang and heats the interior directly. Design move number 3, the rooftop deck. This is the design move that flat roof advocates love to talk about, and for good reason. On a 200 or 300 square foot tiny house, the rooftop deck is not a luxury. It is a functional second floor outdoor living space. You can put seating up there, a small garden, a hot tub if your structural engineering supports it, a meditation space, a place to watch the sunset that you would not have on any other tiny house roof style. The key is engineering it properly from the start. A rooftop deck has to be factored into the structural load calculations from day one. Your roof deck needs to carry the dead load of the waterproofing membrane and decking material, plus the live load of people and furniture. This is not something you add as an afterthought. Plan it in from the beginning, and it is entirely achievable, even on a modest budget. Design move number 4, material contrast on the exterior. Because the flat roof removes the dominant triangular shape from the composition, the exterior walls carry more visual weight. The smartest flat roof tiny house builders use this to their advantage by layering 2 or 3 contrasting exterior materials. Think dark metal panels on the upper half and natural cedar or weatherboard on the lower half, separated by a recessed horizontal shadow gap. Or a monochromatic black stucco box with a single band of warm-toned wood around the entry. The flat roof becomes the clean horizontal cap that lets the material story on the walls do the talking. This approach reads as much larger and more refined than the actual square footage suggests. Alright, here is where the video gets really practical. Because the design ideas are exciting, but waterproofing is where flat roof builds either succeed for 30 years or leak and fail in 5. Let's go through this properly. There are 4 primary waterproofing systems used on flat roof, residential, and tiny house builds in 2026. Each has a specific performance profile, cost range, and ideal use case. Waterproofing Option 1, TPO, Thermoplastic Polyolefin. TPO is currently the most popular choice for residential flat roofs, and it has earned that position. TPO is a single-ply membrane, essentially a large sheet of flexible thermoplastic material that gets heat welded at the seams. That heat welding is the critical word. The seams are not glued. They are literally melted together with a hot air gun and pressed into a single continuous piece. Once welded, the seam is as strong as the surrounding membrane. It does not degrade over time the way adhesive seams do. TPO is also white or light colored, which means it reflects solar heat rather than absorbing it. According to the EPA, cool roofs like white TPO can reduce surface temperatures by up to 50 degrees Fahrenheit compared to dark-colored membranes. On a tiny house, that translates directly to lower cooling loads in summer. Now here is something important to understand about pricing at the tiny house scale. The per square foot numbers you see for commercial flat roofing do not apply cleanly to a 200 or 300 square foot residential roof. Contractors charge minimum trip fees and mobilization costs for heat welding equipment regardless of how small the job is. That fixed overhead gets spread across a tiny footprint, which drives your real per square foot cost up significantly. In 2026, a realistic installed price for TPO on a small residential flat roof is $7.50 to $11 per square foot. For a 250 square foot tiny house roof, that puts your membrane installation cost in the range of $1,900 to $2,750 before system layers. TPO lifespan with proper installation and maintenance is 20 to 30 years. Waterproofing option 2, EPDM, ethylene propylene diene monomer. EPDM is the rubber membrane that has been the workhorse of the flat roofing industry since the 1960s. It has the longest performance track record of any modern membrane system. EPDM roofs installed in the 1980s are still functioning today in many parts of the country. The material is flexible, highly resistant to UV damage and extreme temperature swings, and performs exceptionally well in cold climates, staying pliable and resilient in freezing conditions where TPO can become brittle without adequate insulation beneath it. Historically, EPDM seams were bonded with liquid adhesive applied on-site, which degraded over time with UV exposure and temperature cycling. But by 2026, the industry has shifted heavily toward factory-applied seam tape systems, precision tape that is far more stable and consistent than field-applied liquid adhesive. Modern EPDM seam tape technology has vastly improved the material's long-term reliability, though heat-welded TPO seams still hold the edge in pure seam strength terms. With quality installation and modern seam tape, realistic EPDM service life is 25 to 30 years. At the small residential scale, EPDM runs between $6.50 and $9.50 per square foot installed in 2026, again reflecting the minimum call-out reality of working on a tiny footprint. The standard color is black, which absorbs heat and is a disadvantage in hot climates. White EPDM products are available for an additional cost if energy efficiency is a priority. Waterproofing option 3, PVC polyvinyl chloride. PVC is the premium tier of the single-ply membrane world. Like TPO, it is heat-welded at the seams, creating a monolithic waterproof surface. PVC offers exceptional resistance to chemical exposure, grease, and oils, which makes it the go-to for restaurants and commercial kitchens, but also relevant if you're running any kind of workshop or food prep operation in your tiny house. At the small residential scale in 2026, PVC runs between $9 and $13.50 per square foot installed, the highest of the four options and rarely done as a DIY project because the specialized heat welding tools required are not practical for a one-off residential install. For most tiny house applications where chemical resistance is not a specific requirement, TPO delivers comparable waterproofing performance at a meaningfully lower cost. But if you want the absolute top tier in seam strength and chemical resistance, PVC is the answer. Waterproofing option 4, Modified Bitumen. Modified Bitumen is the evolution of the old built-up tar and gravel roofing system, but modernized with polymer technology. It is an asphalt-based, multi-layer system that bridges the gap between single-ply membranes and traditional built-up roofing. It handles penetrations, pipes, vents, drains exceptionally well because it conforms easily to irregular shapes, making it a practical choice on any build with a lot of rooftop equipment. In 2026, Modified Bitumen runs between $6 and $9 per square foot installed at the small residential scale. One factor to know, Torch-down modified bitumen systems carry higher liability and insurance costs for contractors due to the open flame application process, which is part of what pushes the install price up on small jobs. The main performance limitation is color. It is dark and absorbs heat, which is a disadvantage in warm climates. For cold climate builds with multiple roof penetrations, it is a proven and practical choice with a realistic lifespan of 15 to 25 years. Here is something that most flat roof waterproofing discussions miss entirely. The membrane is only one component of a properly functioning waterproofing system. Think of it as a layer cake, and every layer matters. Layer 1 is your structural deck, the plywood or OSB substrate that everything else sits on, as we covered in segment 4. On a tiny house built from scratch, the most cost-effective and space-efficient way to achieve the required 1/4 inch per foot drainage slope is to cut it directly into the framing during construction. This is significantly less expensive than tapered insulation on a new build, and it preserves interior ceiling height, which is especially critical on a mobile tiny house where overall structure height is constrained. Layer 2 is the vapor barrier. In most climates, you want a vapor retarder between the structural deck and the insulation layer to control moisture movement through the roof assembly from the interior. Get this wrong, and you can trap moisture inside the roof structure, leading to rot and mold that no membrane on top will save you from. Layer 3 is the insulation. Rigid polyisocyanated insulation board, ISO board in industry terms, is the standard choice for flat roofs. It provides high R value per inch of thickness and works well under all 3 major membrane types. Modern hybrid roofing systems in 2026 often layer different insulation types for enhanced thermal performance. Layer 4 is the cover board. Between the insulation and the membrane, many professional installations include a 1/2 inch or 5/8 inch cover board, typically gypsum or wood fiber, that protects the insulation from damage during installation and improves the substrate for membrane adhesion. Layer 5 is the membrane itself, TPO, EPDM, PVC, or modified bitumen, as we just discussed. And layer 6, often the most important, is the drainage design. Where does the water go when it hits your roof? Internal drains, perimeter scuppers, or gutters all work, but they have to be sized correctly and located at the lowest points of the roof. Poorly designed drainage is the accelerant that destroys flat roofs early. Get this right from the beginning, and every other layer in the system performs better and lasts longer. One of the strongest arguments for the flat roof tiny house, especially if you're building for off-grid or low utility cost living, is what the roof can do for your energy situation. Solar panels installed on a flat roof can actually outperform panels on a sloped roof. The reason is positioning flexibility. On a sloped roof, your panel angle is locked in by the roof pitch and direction. On a flat roof, you can tilt the panels using mounting racks to whatever angle maximizes solar capture for your latitude, typically 15 to 40 degrees, regardless of which direction your tiny house faces. Well-designed flat roof solar systems can achieve 10 to 15% higher energy yields than equivalent sloped roof installations. Now, you may have heard that the standard approach for flat roof solar is a ballasted mounting system. Frames weighted down with concrete blocks that hold the panels without penetrating the membrane. And while that works well on large commercial buildings, it is not the right call for most tiny houses. A proper ballasted system adds 4 to 8 pounds per square foot of concrete weight to your roof. On a 250 square foot tiny house roof, that is potentially 1,000 to 2,000 pounds of ballast. For a light gauge steel or wood frame tiny house, especially a tiny house on wheels, that is a structural problem, not a solution. In 2026, flat roof tiny house builders are choosing smarter options. The first is a mechanically attached, lightweight rack system that integrates directly into the roof framing. No ballast weight, secure attachment, and a clean, low-profile result. The second is even more cutting-edge, peel-and-stick flexible solar laminates, often using CIGS photovoltaic technology that bond directly to the surface of a TPO or EPDM membrane without any penetrations and without any ballast weight at all. These thin film laminates add minimal structural load, preserve the membrane integrity, and produce real usable power. They represent the direction the tiny house solar market is moving. One important rule regardless of which mounting method you choose: panels should never be installed completely flat against the membrane surface. A minimum 10-degree tilt is required, both to maintain manufacturer warranties and to allow rain to wash accumulated dust and debris off the panel surface. Without that angle, panels lose efficiency and accumulate grime quickly. For a tiny house specifically, most off-grid or hybrid setups run between 1 and 5 kilowatts of solar capacity. Before installation, confirm your roof structure can handle the additional load of the panels and mounting system you are choosing, and build that calculation into your framing plan from day one. We need to address this directly because the question always comes up: can you build a flat roof tiny house in a cold or snowy climate? The honest answer is yes, with important caveats. Snow accumulation is the primary structural concern. Flat roofs do not shed snow the way pitched roofs do. Snow has weight. Wet, heavy snow can reach 25 to 40 pounds per square foot or more, depending on conditions. Your roof structure needs to be designed with that live load accounted for explicitly. This is not optional and not something to estimate informally. Get a structural calculation done. The membrane selection also matters in cold climates. EPDM has the best cold weather flexibility of the major membrane options. It remains pliable and resilient well below freezing. TPO can become brittle in extreme cold if the insulation layer beneath it is insufficient. In cold climate flat roof builds, insulation thickness needs to be higher than in moderate climates to keep the membrane surface temperature above the point where cold embrittlement becomes a risk. Additionally, flat roofs in cold climates need to be designed to handle ice dam potential at the perimeter. Proper insulation levels above the living space, combined with well-designed drainage that routes water to heated interior drains rather than open-air scuppers, is the standard cold climate flat roof strategy. Bottom line, cold climate flat roof tiny houses are built, and they perform well, but they require more intentional engineering than the same roof in Phoenix or Austin. The design has to account for the climate from the beginning. All right, we promised you this at the start of the video. The single most common cause of flat roof failures. The thing that takes a well-intentioned build and turns it into an expensive repair within 10 years. It is not the membrane choice. It is not the climate. It is not the size of the house. It is ponding water. Ponding water is what happens when water sits on a flat roof surface for more than 48 hours after rain stops. It happens when the slope is insufficient, when drains are clogged or undersized, or when the roof structure deflects over time, creating low spots that were not there on the day of installation. Here is why it matters so much. A pond of water sitting on your roof does not just add structural weight. It actively degrades adhesive bonded seams over time. It creates sustained hydrostatic pressure that finds and exploits micro-imperfections in the membrane. It breeds algae and biological growth that chemically attacks certain membrane materials. And it freezes in winter, expanding and contracting repeatedly against the membrane surface and any flashing details at the perimeter. The solution is not complicated, but it has to be built in, not added later. Build your drainage slope directly into the framing from day one. Size your drains or scuppers correctly. Keep them clear, and design the entire roof surface so that every low point in the system leads to a drain, not to a corner where water can pool undisturbed. If you take one thing from this video and apply it to your flat roof tiny house build, let it be this: design your drainage system before you design your membrane system. Solve for water movement first. Everything else follows. Let us pull the numbers together so you have a realistic picture of what a flat roof system costs on a tiny house built in 2026. And these are genuine small project numbers, not commercial economy of scale pricing. For a 250 square foot flat roof, here is how the membrane options stack up at realistic installed costs. TPO at $7.50 to $11 per square foot installed puts your membrane cost at approximately $1,900 to $2,750. Add vapor barrier, ISO board insulation, cover board, edge flashing, and drainage hardware, and a complete turnkey contractor price in 2026 lands in a range of $4,500 to $7,500. That is the real number, not the commercial brochure number. EPDM at $6.50 to $9.50 per square foot installed puts the membrane cost at $1,600 to $2,400 for that same footprint. Complete system cost, including all layers, runs approximately $4,000 to $7,000 at the small residential scale. PVC at $9 to $13.50 per square foot is the premium option. Membrane cost alone runs $2,250 to $3,400. For most tiny house applications without specific chemical exposure requirements, TPO delivers comparable performance at a lower number. Modified bitumen at $6 to $9 per square foot sits close to EPDM in total cost, with the trade-off being lower energy efficiency due to its dark color. Best suited to cold climates with complex penetration layouts. These numbers cover the waterproofing system only, not the structural roof deck, framing, or rooftop features like decking or solar. But they give you an honest benchmark for budgeting the critical envelope layer, with the real-world contractor costs that actually apply at the tiny house scale. Let's be direct. A flat roof tiny house is not the right choice for every builder or every site. Here is who it works best for. It is a strong choice if you're building in a dry or moderate climate, the American Southwest, the Pacific Coast, the Southeast outside of hurricane zones, or much of the Mountain West. In these climates, ponding risk is lower, snow load demands are minimal, and a well-installed TPO or EPDM membrane will perform reliably for decades. It is a strong choice if you are building a stationary tiny house on a foundation, slab, or permanent pier system. This is where full design freedom lives. You can do the rooftop deck, the deep cantilevered overhang, the full solar array on lightweight racks. None of that is in conflict with your structure when the home stays in one place. If you are building a tiny house on wheels, hear this clearly, a flat roof can still work. But you need to be conservative with overhangs, deliberate about wind loading at highway speeds, and honest about the structural limits of a mobile chassis. Deep overhangs on a highway-rated THOW create dangerous wind shear, lifting forces at speed. That is not a detail you want to discover after the build is done. Keep the profile tight, keep the overhangs modest, and the flat roof on a THOW becomes a clean, low-drag aesthetic rather than a structural liability. It is a strong choice if rooftop functionality is a priority, solar, a deck, a garden, or rainwater collection. These features are dramatically easier to incorporate on a flat roof than on a gabled or shed roof. And it is a strong choice if modern minimalist aesthetics are part of your vision. If you want a home that looks intentional, clean, and architecturally confident, the flat roof tiny house delivers that aesthetic more directly than almost any other roof style at this scale. The flat roof tiny house is not a shortcut, and it is not a compromise. When it is designed and built correctly, with proper slope built into the framing, the right membrane system for your climate and budget, quality insulation layers, and drainage that actually works, it is one of the most elegant, functional, and forward-thinking builds in the affordable housing space. Build your slope into the frame. Choose your membrane based on your climate, your build type, and your realistic contractor costs. Solve the drainage question before you solve the membrane question. And if you're in a cold or heavy snow climate, get a structural engineer involved early, not after the framing is done. Do those things, and you will have a roof that looks incredible, functions without drama, and serves you for 25 to 30 years. If this video helped you think through your build differently, hit the like button. It genuinely helps this channel reach more people who are working through the same decisions you are. Subscribe if you have not already, and check out the video that pops up on your screen now. We have a deep dive on modern tiny house design moves that pairs perfectly with everything we just covered. I will see you in the next one.